Geometric series is an expression of the sum of the terms in a geometric sequence. Remember, a geometric sequence is found by using a common ratio and multiplying each term each time to get the next term. A geometric series simply means we're going to add all those terms up. So the word series means we're going to add them up. Arithmetic series, we add it each time to get the next term. And so an arithmetic series, as we did yesterday, we added all of them up. Just like yesterday, we have finite and infinite. Finite means we have a specific number of terms, 10 or 5 or 20 or 100. Infinite means it goes on and on and on and on and on. Okay? We have a couple formulas to write down. Pause for a second. It's important to acknowledge that I didn't write it to begin with. The sum of a finite geometric series. This formula only works if there's a finite number of terms. There's exactly 7, or there's exactly 100, or there's however many they say, but there's a definite number of terms. It's not an infinite number. It doesn't go on forever. Okay? Okay, here's an example. And like yesterday's example, I'm making it a little harder because I'm not telling you how many terms there are. Okay? I did not tell you how many terms there are. But we can discover how many terms there are. We can use our hand and multiply it by 2's if we want. Or we can acknowledge that each time to get to the next term, I'm multiplying by 2, right? So my common ratio is 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 would be 16. I could go on and on and on, okay? So I get the first term. So my formula, my formula would be something like 2 to the n, right? I might look at it as 1 times 2 to the n, but it would be the same thing. 2 to the first power is 2 to the second power is 4 to the third power is 8. So here's my formula. So that means 2 to the n would have to equal 128. Okay? Remember logs we worked on? I could say log of 2 to the n is equal to log of 128. That means n log 2 equals log 128. This is not the only way it can be solved, but this is the best way if your calculator doesn't do a change of base. Okay?
Why not just do 28 divided by 2?
Because I'm not multiplying by 2, I have 2 to the n power. N is not equal to 64. When you're solving for an exponent, you either have to write this as a base to some power, which sometimes is hard to do, or you have to use logs to solve for an exponent. Okay? And So if I divide both sides by log 2,
2.63.
I don't think so. Try it again. If you got 2.63, what did you do? Oh, okay. You forgot to end this parenthesis before you divided?
Yeah.
Okay. Good. That's a simple fix. Okay? So n is 7. So that means how many terms do we have? 7. So if I use my formula, S of 7 is going to equal a sub 1, which is 2, 1 minus r, which was 2, sorry, 2 to the 7th, over 1 minus 2. Okay? And so we get 2 times, what's 2 to the 7th? 128, so this is a negative 27, sorry. Over negative 1. Do you agree my negatives are going to cancel? I have a negative 2 times a negative 127 divided by negative 1. So if I just multiply, what do I get? 254. Okay.
So why couldn't our pattern been n times 2? But you're going 2, 4, 6.
I'm not going 2, 4, 6.
2 for 8.
Yeah.
So
That's
when
why.
I-
If you go 2 times n, you're going to get 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. Those aren't the terms of my sequence. It's not arithmetic. Okay, it's geometric. Okay? And so we have to look at a geometric sequence, which if we've forgotten what they are, then we have to go back to lesson probably 3. Geometric sequences, lesson 3. It says a sub n equals a sub 1 times a sub n equals a sub 1 times r to the n minus 1. Okay? And so this, if we follow this, we get 2 times 2 to the n minus 1. Okay? Well, what's 1 minus 1? 0. So that first term,
Would that be 1?
it'd be 2 times 1, which is 2. And so, because these numbers are the same, then it's a simpler form to write this simply as 2 to the n. So 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8.
I thought you were talking about 1 minus 1 up there. I thought the n was 1. So it would be 1 minus 1, which would be to the 0.
It is.
So it would be
And 2 to the 0 power is
1.
1 times 2 is 2. That's how I get the first term. If I use the formula they gave you in lesson 3, I would get, this is overkill here. I'm multiplying by 2 and then I'm multiplying by another 2.
Yeah.
Because these are the same, this simplifies
Oh, so
to
it's
this.
a common ratio of 2.
Yeah.
Oh, that's
Yeah, the common ratio is 2, which is also the first term.
yeah.
Okay, if I went 6, 12, 24, if I went like this, now my first term and my common ratio are not the same number. So I have to look at it as they do in this
Yeah.
formula here. But in our example, the 2 and the common ratio was also 2 being the same number. it does simplify to a simpler expression. Okay?
Okay.
All right. If we wanted to, there aren't that many terms. 16, 32, 64. Those are the only terms missing. We could add all those up. What do you think we should get? I think we have a mistake, though. No, we got it right. We should get 254. I was thinking 57. It was 127. I was looking at all those even numbers saying there's no way we should get an odd number. Go ahead, Max.
Wait, come on. I was trying to do the math in my head, and it didn't work, so it's fine.
Okay, I've been there before. Trying to do math in my head and sometimes I fail. All right, are you okay then?
Yeah.
Do we have any other questions? Okay. Pause for a minute. In an infinite geometric series, there's two types. When the absolute value of the ratio is less than 1, then it converges. Converges means it approaches a number. Okay? When it's greater than or equal to 1, that means it diverges. Alright? So when it's less than 1, when r is less than 1, it's going to converge onto a number. When it's greater than 1, it's going to diverge. It's going to go away from. Okay? It's going to keep getting bigger and bigger and bigger, or smaller and smaller and smaller. It's not going to approach a certain number. Okay, kind of like limit. Okay. All right. An example of converging. If I had, let's pick a nice number. If I had 8 1/2 to the n. Okay? And this was our sequence, not the series, our sequence. Okay? And so my terms would be 8. And then, so my series, my terms would be 8 plus 4 plus 2 plus 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus 1/64 plus 1/128 plus 1/256 plus 1/512 plus 1,024. Get any idea? What's happening to this number? I'm dividing by 2 each time. I'm multiplying by half each time. It's a common ratio. But what's happening to the value of that number?
It's getting technically smaller, but the bottom number is
The bottom number is getting bigger, making the value of the fraction smaller. What number is that approaching? 0. At some point, this bottom is going to be so big that the value of that is not going to be worth anything, is it? It's never going to get to 0, is it? That's kind of what an infinite series looks like. It's never going to get to a number, but sometimes when it converges, that means it's approaching a number, and at some point we're not going to be adding any more to it, are we? I mean, if these were dollars, $8, yeah, that's nice, and 4 more, and 2 more, and 1 more, and even a half a dollar, kind of like that, don't you? 12, 14, 15 and a half, 15.75. But after that, even then, it starts to get pretty small, doesn't it?
At least you can pay gas stations for a fraction of a cent. Like when it's
Yeah.
a fraction of a cent.
Right. Okay, but my point is, at some point in here, and you can draw the line wherever you want, you would say if we're talking about money, well, there's no point, you can have the rest. Right? You'd say if this was your money, and I'm giving it to you, and you want to be generous, you say, well, I'll just take this much, have the rest. You can have all of these dollars down here. Okay? If I take all those dollars, I can not buy a paperclip. I wouldn't have enough. Okay? Actually, with the 1/8, I probably would. But see, hopefully you see what I'm saying here. So this sequence is converging onto a number, which means my sum is going to converge towards a number. Okay? And we have a formula for that. Let me pause so we can write that down. So in the sum of an infinite geometric series, if absolute value of r is less than 1, then the sum converges to this value right here. And I started to say, notice there's no n here. There's no n on that s. The reason there's no n on that s is because n represents the number of terms, right? And this is an infinite series, which means there is no limit to the number of terms. It goes on forever. Okay? And so our sum is going to approach this number. It converges to this number. Does that mean this is exact? No, it just means that for all points that matter, this is good enough. Okay? So it's going to approach. And so we need the common ratio and we need the first term. And so if we go back to 8 plus 4 plus 2 plus 1 plus okay, what's my first term? 8. Divide by 1 minus my ratio. What was my ratio? 1/2. Remember, it had to be less than 1. Okay? And so we end up with 8 over 1/2. 8 over 1/2. No? 1 minus 1/2 is a positive half. Okay? You have $1 and I take half away, you have a half a dollar, right? So what's 8 divided by 1/2? 16. So my series that I had used as an example on the last screen, we said we got to 1575 and I said you could have the rest, so the rest was going to add up to about 25 cents. Yeah, I should be saving that. If I had enough of those, I could almost do a load of laundry. All right? So that's how we use this formula for a geometric infinite series that is converging. Okay? There is no formula for one that diverges. All right? This may change a little bit. For right now, this is what I have for our the rest of our semester. Today we're doing 2 to 42 evens on 11.5. Tomorrow we're going to do 1 through 11 all on 11.6. They're a little time consuming. Tomorrow they're not difficult, but they're a little time consuming. You probably won't see them again until pre-calc or maybe even calculus, but something that if we talk about a little bit tomorrow, then at least when you see them again, you will think, oh yeah, I remember doing a little bit of that. Okay? And then on Friday, without a review, without anything else, we're doing a group quiz to finish up this chapter. I'm not going to give you a Chapter 11 test separate from the final exam. Your exam is on Thursday. Okay? And so, guys, please stop. Your exam is on Thursday, and so we will review Monday and Tuesday, and Wednesday I don't know exactly what's going to happen. So Monday I will have a meeting with Mr. Faust. Do you remember him? He observed class once.
I remember him.
And the math department is all meeting with him on Monday, so all of us will have subs and, not from Subway, unfortunately. Anyway, I'll give you your worksheet that day, your study guide or your review, whatever you wanna call it, and you'll begin working on that. You need to get after it though. Some of you are behind on some of the skills that we learned in this semester, and I have to expect some of you to be wanting to stay after school, yet I've not heard that from anybody yet. So, I won't do it Friday, I won't even be here to finish the day Friday.
Where you going?
I'm going to, Vince's track meet.